Alright, let's continue with example 7. You are given the continuous random variable x has the property density function. So you are given the PDF. And for the part A, find the value of the constant A. So by remembering that the definition of continuous random variable, which is the integration of fx dx from the lowest limit to the uppermost limit should equals to 1. Okay, you need to be remember that it should be equals to 1. So by taking this definition, we're going to solve it for A. Okay, the difference with this question, you are given with two non-zero functions. We have 1 and 2 non-zero functions. So of course we are going to integrate these two functions. So we're going to start with the integration of the first function, which is the limit is from 0 until 1 over 2 with the function a over 3 minus ax over 3 tx plus with the second function. The second function is varies from 1 over 2 until 1 with the function ax over 3 dx, and we should equate to 1, okay, by taking these definitions. Okay, so we are going to solve it. So since we have a over 3, so we can take out, it's better we take out the a over 3, factorize the a over 3. So then we will get a over 3 integrate with 1 minus x dx with the limit 0 to 1 over 2 plus with this one also we can take out the a over 3. Just take out the a over 3. Then it will make it easier for you to integrate. Right, equals to 1. Now this should not equals. Okay, so then we are going to integrate. We're going to integrate. Okay, for the first function, integrate 1 minus x. So we have the a over 3 outside here. So integrate 1, we get x. Integrate x, we give you x squared over 2 with the limit 1 over 2 and 0. Plus with a over 3. Integrate x, we will get x squared over 2 with the limit equals to 1. Okay, since we have a over 3 for both terms for the left side, we can multiply with 3 in order to eliminate the 3. It's an option. If you don't want to do it, just forget the multiplication of 3. So then we are going to substitute. So after we multiply each term with 3, so then for each denominator of 3, we'll get rid. So we're going to have a multiply with substitutions of limit, which is substitute 1 over 2 minus 1 over 2 squared over 2 minus with substitute 0 plus with a multiply with substitute the limit, so we get 1 over 2 minus 1 over 2 squared over 2 equals to 3. Okay, so the rest is just simplifying, and you should simplify every single things that we have right now. So at the end, you will get a is equal to 4 as the final answer. Right, then we're going to proceed with part B. So for part B, the question asks to find the probability for x varies from 1 over 3 to 2 over 3. So you have to understand that in order to find the probability from 1 over 3 until 2 over 3, it means we have to find out the area. So we have to find out the area from 1 over 3 to 2 over 3. Since for this question we have two non-zero function. We have two non-zero function which is from 0 until 1 over 2, from 0 until 1 over 2. So I'm going to erase this. From 0 until 1 over 2, and continue from 1 over 2 until 1. Okay, back to the question. Question asks from 1 over 3 to 2 over 3. So you just jot down where is the 1 over 3. So 1 over 3 should be in between of this value, and this should be 2 over 3. So means we have to find out this area. Okay, all those areas are separated at this value. Means that from 1/3 to 1/2, we're going to differentiate, we're going to integrate different function with the other one. So means we have to separate these two, become two integration. So means that we have to integrate from 1/3 until 1/2 for the first function, which is, the first function is a/3 minus ax/3. Since we have find out the a, which is 4, so it means we have to integrate 4/3. We have to integrate 4/3 minus 4x/3 dx plus with integrate. The second part is from 1/2 until 2/3. So 1/2 to 2/3. For the different function, which is 4x/3 dx. So we have to integrate all those functions. So you can just take out the 4/3. It's better we take out the 4/3. So then we have to integrate 1 minus x dx with limit 1/3, 1/2 plus 4/3. Integrate from 1/2 until 2/3 for the x. Alright, so integrate 1, you get x minus x squared over 2 with 4/3 outside here. This is 1/2, this is 1/3 plus with 4/3 with integration of x is x squared over 2. This is 1/2. Okay, so next is the process of substitution. You just need to substitute every single limit that we have here. So substitute 1/2 minus 1/2 squared over 2 minus with 1/3 minus 1/3 squared over 2. We have to put the bracket here. And then plus with 4/3. Substitute 2/3 squared over 2 minus 1/2 squared over 2. Right, substitute and calculate. You just put inside the calculator. So at the end, you will get 7/27. Okay, then we are going to continue with part C. Find the expected of x, expected of x squared, and the variance of x. Okay, we're going to start with the expected of x. So to find the expected of x equals to integration of from the lowest to the highest of x multiplied with fx dx. So it means that the expected for this function is integration from the first function given. We are going to integrate from 0 until 1/2 with the multiplication of x with the fx, which is the function here is 4 over 3 minus 4/3x dx plus with integration for the second function, which is from the interval 1/2 until 1, and x multiplied with the function 4/3x. Right, so to make it easier, we can just take out the 4/3 outside. So just take out 4/3. So then we will have integration for x multiplied with 1 minus x plus with, right, plus with, factor out the 4/3, take out the 4/3, so 1/2 until 1, and you just expand the x square, the x and x, you get x square. Alright, this one need to be more, need to be expanded before we integrate. So 4/3, 1 until 1/2, so then you will get x minus x square dx plus with 4/3, 1/2 until 1 for the x square dx. Then we are going to integrate. So integrate this will give you x square minus x cubed over 3 with the limits plus 4/3 multiplied with the x cubed over 3 with its limit. Then substitute. You have to substitute every single thing. So 1 over 2 squared minus 1 over 2 cubed over 3 minus with 0 plus with 4 over 3 multiply with 1 cube over 3 minus 1 over 2 cube over 3. So you just need to calculate, and you will get the final answer. You get 1 over 2 for the expected of x. Okay, then we are going to continue with finding the expected of x squared. So to find out the expected of x squared is equals to integration from the lowest to the uppermost limit for the function x squared multiply with, for the x squared multiply with the function of fx. Okay, so means the expected of x squared for this function is equals to integration from 0 until 1 over 2 for the function x squared multiply with 4 over 3 minus 4 over 3 x dx plus with the second function, which is from 1 over 2 until 1, the function x squared multiply with 4 over 3x dx. Okay, this is something that you have to remember, that you have to multiply x squared for all those functions. And then we are going to simplify. The same way, I'm going to factor out this 4 over 3. So means that outside here should be 4 over 3. And then with the limit, and then x squared need to be expanded with 1 minus x dx plus we factor out the 4 over 3 also. And then x squared multiply with x will give you x cubed. This is the limit 1 over 2 until 1. Alright, so we're going to expand first before integrate. So 4 over 3 integrate from 0 until 1 over 2. So expand, so we get x squared minus x cubed dx plus with 4 over 3 integrate for x cubed dx. So we are going to proceed with the integration. So 4 over 3 multiply with integration of x squared will give you x cubed over 3 minus integration of x cubed will give you x power 4 over 4. Okay, with its limit, and plus 4 over 3 integrate x cubed will give you x power 4 over 4, which is the limits 1 over 2 until 1 over 2 until 1. So proceed with the substitutions. So we're going to substitute each of the limit. Substitute, so we have 1 over 2, 4 minus 0 plus with 4 over 3, 1 power 4 over 4 minus 1 over 2 power of 4 over 4. Alright, so calculate all those things, which is at the end you will get 25 over 72. Okay, so we have done for the expected of x squared. And then lastly, the question asks for the variance. So you should know that the variance is equals to the expected of x squared minus with expected of x bracket square. Okay, I'm going to make it in the box. So we are going to calculate for the variance. So variance is equal to expected of x squared, which is 25 over 72 minus with expected of x. Expected of x is 1 over 2. So we're going to substitute 1 over 2 here. So 1 over 2 squared. Okay, just be remember of the squared. And then calculate, which is the final answer is 7 over 72. Okay, that's all. Okay, now we are going to proceed with the example 8. The question states that x is a continuous random variable with the probability density function. So this is the PDF. With the function fx equals to 1 over ax, where the x varies from 0 until 4. And the question A, for the part A, asks to find the cumulative distribution function. So the question asks to find the CDF, which is, so we can write it in another notation, which is using the capital letter of F. So you have to remember that in order to find out the CDF from the PDF, if you are given the PDF and you want to find the CDF, so what you need to do is you have to integrate. You have to integrate every single function that you are given from the PDF in order to convert it from to the CDF. Okay, so before that, we are going to speed up how many interval we are going to identify how many interval that we have to form in order to find the CDF. So how are we going to do that? Okay, back to the question. Since the question just only give you one non-zero function with the limit from 0 until 4, or you can just write, if we write it in this form, in this interval form, which is, this is from 0 until 4. From 0 until 4 is for the non-zero function, and for the other interval is for the zero function. So from here, we can notice that altogether, we have 1, 2, and 3. Altogether, we have 3 interval that need to be find out the CDF, the capital letter of fx. So to find the CDF, we're going to write it in the form of table. This is just an optional to make it more systematic, to find out this, to make it your working more systematic. It's just optional to write it in the table. So we're going to start with the first interval. Okay, this is the first interval. So this interval is actually refer to the x less than 0. This is the x less than 0. So how are we going to find the capital letter of fx, or in other words, the CDF? Okay, just remember that to find the to write on the notation for CDF, you need to use the capital letter of f. Okay, equals to, we're going to integrate, since we're going to find out the CDF, so we're going to integrate from, we're going to start from the negative infinity. We are going to start from negative infinity, integrate until x. We are not going to integrate from until 0, because 0 is the maximum for that interval. Okay, so we're going to write it as x, negative infinity to x. Why we write it as an x? X actually representing any value on that range. It means that from negative, it could be negative infinity to negative 1, for example, negative infinity to negative 10. So x is a variable that representing any value from that range, maximum to 0. So that's why we're not going to integrate from negative infinity to 0. It should be until x. So what the function that need to be integrated here? It should be 0, because this is the area where the 0 function. This is a 0 function. So we are going to start, we are going to integrate 0. So since we are going to integrate 0, so then we get 0 function for the first interval. Okay, so for the f of c is actually, we are going to substitute the upper limit for that interval. So this is the upper limit. Okay, this is the upper limit. So this is the value of c. We're going to substitute c into the fx. Since the function of fx here is 0, we're going to substitute 0 into the 0 function, which is f of c will give you 0. Okay, then we're going to proceed with the second interval. Okay, so this is the second interval. Okay, so you have to remember that since this is the cumulative, this is the cumulated function. We are going to accumulate from the starting, which is from the negative infinity and onwards. So write the interval first. So this is the interval for the x varies from 0 until 4. So to write on the function of fx here, it should be f of 0 plus with 0 to x. Okay, 0 to x. Okay, why it should be f of 0? This is the cumulated. We have cumulate from the starting from the negative infinity until until f0. This is the f0. This is the cumulative. So we're going to accumulate from the starting. So before we are entering this interval, we already accumulate from the first interval. The first interval we accumulate for the f0. So for this one, f of 0 plus with integration of 0. So why we are starting from 0? So this is the starting for the second interval. This is 0. We are going to integrate until x. 0 until x. It's not 4. We are not integrate until the maximum. Okay, we are going to integrate from the starting, which is 0. From the beginning is 0, beginning of that interval, until x. Because x represent any single x for that interval. It could be 0 until 1, it could be 0 until 2, it could be 0 until 3.1, it could be 0 until 3.9, any value of x up to 4. So, we're going to substitute what fx should be here. So, since this is a non-zero area, which is the function fx is located here, so we are going to integrate 1 over 8 x dx. Okay, so what's the value of f of 0? F of 0 is come from here. Alright, I do some mistake here. It should be f of 0. It's not f of c. It should be f of 0 here. Okay, so f of 0 from the first part, we have find out which is 0. So we are going to equals to 0. This is the 0 plus with integration of 1 over 8 x. It will be 1 over 8 x squared over 2 with the limit 0 until x. So then, if you simplify it, we substitute. We are going to have 1 over 8 of x squared over 2 minus 0. So that will give you x squared over 16. Okay, that will give you x squared over 16. So then, for the last column, we are going to find out f of 4. Why it should be 4? Because this c is actually your upper limit for that interval. So the upper limit is here is 4. So we're going to find out the f of 4. So how are we going to find out f of 4? So we have to substitute this 4 into this function. This is the fx that we have found out. So you just need to substitute 4. So then we will substitute 4 squared over 16. You get 1 for this part. Okay, and then we're going to substitute for the last interval. This is the last interval. Okay, last interval is for the x greater than 4. It's for x greater than 4. And the function here, it should be fx equals to, since we are starting from, for this interval, we start from 4. We have to integrate from 4 until x. So, but you have to remember that before you entering this third interval, you have accumulate from the starting. So the accumulation from the starting until 4 is referring to the f of 4. So we are going to start with fx equals to f of 4 plus with integrate from 4 until x with the function 0. Okay, why 0? This is the 0 function. Because you just only, the question just only give you one non-zero function, which is 4, 0 until 4. Okay, so for the f of 4, we already find out from the previous part, which is this is the f of 4. So we're going to substitute here. This is equals to 1. And for the integration of 0 gives you 0. So at the end, we end up with 1. So that is our target. So in order to find the CDF, you have to remember that, you have to bear in your mind that the last function should be 1. You should end up with 1. So then you just stop. Okay, so that's the final step. Okay, so to write on the final answer should be write on in the form of piecewise. So this is the CDF. Going to write out. Okay, so you just copy down all the interval with the fx, but we start with the fx first. Okay, so this is the first function, which is 0. We are going to write it 0 for x less than 0. And then we're going to start with next, which is x squared over 16. We're going to write on is here x squared over 16 for the x greater or equal than 0, less or equal than 4. And lastly, 1. Okay, it should be 1 ended with 1. So here for the x greater than 4. Okay, we have done for the finding CDF from PDF. Okay, then we are going to proceed with the second part, which is B. The question asks to sketch the graph of y equals to f, capital letter of f. So you must be careful with the notation here. This is the question asks to sketch the graph for the CDF. This is the CDF, not the PDF. Okay, the notation here is referring to the CDF. So means that we are going to sketch this graph. Okay, we are going to sketch this graph. Right. So back to the fx CDF that we have to find out before that. So altogether we have 3 functions starting from 0, and then the second function continue with the quadratic and end up with constant. So for the quadratic function, okay, we're going to start with the quadratic function. We are going to write it here, fx. I'm going to take out the function x squared over 16. Okay, the minimum here should be 0, 0. And then since the interval is varies from 0 until 4, so we're going to find out these two values. So we're going to calculate to find out the f0 and also f of 4. So f of 0 should be 0 over 16, so equals to 0. So this is the minimum point. It's the same point with the minimum point. So f of 4 equals to 4 squared over 16, which is give you 1. So we're going to sketch the graph. Right, we're going to start with this point. We're going to start with this point, which is 0, 0. Okay, this is the 0, 0. This is the 0, 0. And then end up with 4, 1. So 4, 1, let's say this is the 4. This is the 1. Okay, I'm going to denote it as just a blank dot, because since this is an included value, 0 and 4 is included. So we're going to start with the black dot, ending with the black dot. Okay, just connect these 2 points using the curve. Just sketch the curve form. Okay, and then we have settled for the quadratic, and then we are going to proceed with the constant. Okay, fx equals to 1. So this is the constant function from x greater than 4. So we're going to sketch here from 4 and onwards. Okay, just continuously going to the right side. Okay, and then make sure you label the axis. This is the x. This is the capital letter of f. Right, so we have done for the sketching for the CDF function. Okay, the next part, C. Question asks to calculate the probability. This is the probability for x less than 1. So when it comes to continuous random variable, you have to know that for the capital letter of fx, which is the CDF, is equals to the integration of negative infinity to x, the function here fx dx, equivalent also to the probability of x less than x, also equals to for x greater or x less or equal than x. So the things that need to be highlighted here is when it comes to the continuous, okay, it doesn't matter whether it has no equal sign. It just only the sign is just the less sign or less or equal. It doesn't matter whether it has an equal sign or don't have the equal sign, as long as the sign is less than, it's equivalent to the capital letter of fx. Okay, why these two things are equivalent? Why these two things? Px less than x, it should be equals to px less or equal than x, because px equals to x equals to 0. Okay, since this is the area that we have to find out, for the x equals to x, it actually doesn't give you any area on that, so that's why it's equivalent. Less than or less or equal is just equivalent. So for this question, since the question asks for the x less than 1, so it's actually equals to px less than 1 equals to the capital letter of 1. Okay, why we convert this into the capital letter of f? Okay, so since from the previous part we have find out the CDF, we have find out the CDF function, we have found out the CDF. We already have the function for the cumulative, so it's better we are using the cumulative function to find out the probability rather than using the PDF. If you are going to use the PDF, you need to integrate. Okay, if you don't have the CDF, you just only the PDF, you have to use this kind of method. You have to integrate. But now the situation is we already have the function of fx. So in a short way, we are going to use this rather than integrate. So how are we going to find the f of 1? So we are going to substitute 1, x equal 1, into the correct function. So what is the correct function? So we are going to go back from the previous part. Okay, here we are going to use this function. Okay, now we are going to substitute the x equals to 1. So we have to find out where is the location of x equals to 1. So x equals to 1 obviously is in between of this this interval. X equal 1 is located here. So it means that we are going to substitute 1 into this function. Okay, so back here. So means we are going to substitute into the x squared over 16. So it should be 1 squared over 16. So the answer should be 1 over 16. Okay, so we have settled for the C1. Then we're going to go for the second. This one, x greater or equal than 3 over 2. The sign here, the question asks for the greater. In order to use the capital letter of f, which is the CDF, we have to make some rearrangement. Okay. So since the question asks for the greater, so we can convert it. We can change it. It's equals to, I think I should write here, px greater or equal than 3 over 2 is equivalent to 1 minus px less than 3 over 2. Okay, you have to convert in another way, which is give you the same meaning. So when we change the equation, so then here we get 1 minus, since this is already less than, so we can change 1 minus f of 3 over 2. So then we can use the capital letter of f. So means we are going to use the CDF. We are not going to integrate once again because we have find out the CDF. So then we are going to substitute 3 over 2 into the correct function. So back to our CDF. So 3 over 2 is 1.5. So 1.5 obviously is between 0 to 4. So we are going to substitute into the same function. So 1 minus 3 over 2 squared over 16. Okay, we are going to substitute into this function, x squared over 16, which is for the x greater than 0, less or equal than 4. We're going to substitute into this function. So and then calculate, at the end you will get 55 over 64. Okay, and proceed with next. For this question, ask to find x greater than 2, less or equal than 3. So this is in between of two values. So you can just right away write down f of 3 minus f of 2. Okay, f of 3 minus f of 2. It should be f of the upper limit minus f of the lower limit. Okay, so and then we're going to substitute 3 and 2 into the correct function. So since 3 and 2 is located in between of 0 and 4 also, so we're going to substitute into the same function. So it should be 3 squared over 16 minus 2 squared over 16. So then calculate, and you will get 5 over 16 for the final answer. Okay, lastly, we are going to proceed with the last part for this example, which is find the median. Okay, when it comes to median, everyone should understand that this is the half. So what half for this part, for this questions, right? So since that we should know that the total area for the continuous random variable. Okay, so I just copy down here. This is the function. If the total area, let's say from A to B, let's say the function is bounded from A to B, since this is the area. If the total area, since the total area should be 1, when it comes to median means that the value of x. Median is the value of x that cut the area into the half. So means we want to find out half of the area. It should be 0.5 and 0.5. So what's the value of x here? This is the median. So we want to find out this x, which is cut the area into half, the first half and the second half. Okay, so for the notation, we can write it for the notation. We can write it f of m equals to 0.5. So why is m? It's just an optional. You can write it as fx. Okay, why it's m? M actually refer to the median. Okay, you can just write it f for the fx because m is actually the value of x. Okay, why it should be f, capital letter of f? Because capital letter is referring to the cumulative. We want to accumulate from the beginning until to what value of x, so that the total area should be 0.5. So this is the f of m. Okay, we are going to accumulate from the beginning until what value of x, which is m here, equals to 0.5. Okay, so since we have find out the CDF, we are going to find out the median using the CDF, not the PDF. It's different way. So since we already have the CDF, we're going to use it. Okay, so you have to check, since this question just only have the one function, okay, which is could be locate the x that could give you the 0.5, because the first function already eliminated, because that will give you 0 for any range of this interval. For any x for this interval will give you 0 probability. Means that f -1 equals to 0, f -2 equals to 0. Any x for this range will give you 0. So it's already eliminated. Okay, for the last function, for this x greater than 4, means that if f5 will equals to 1, f6 will equals to 1, f6.1 will equals to 1. So every single x that greater than 4 will give you 1. We want to find 0.5. We want to find that what value of x that will give you 0.5. So means that the x that we want to find out, it should be in between this range. Okay, the value of x that we have to find out should be in between this range. It should be in between of 0 until 4. It could be 0.1, it could be 0.2, it could be 2, it could be 3, any of x. So means that what we need to do is we're just going to substitute amp into this function. Just going to substitute here. So that will give you m squared over 16 equal to 0.5. So I'm going to solve it. So m squared equals to 8. So that will give you m equals to plus minus set of 8, which is set of 8 will give you 2 set 2. Okay, so now we have two possibility of m, whether it is positive 2 set 2 or negative 2 set 2. So since m should be in between this range, m should be between of 0 to 4, therefore the acceptable m here should be positive 2 set 2. The negative 2 set 2 should be rejected because it's out of the range.